Engineering economic analysis is the application of quantitative and qualitative techniques to compare different engineering design alternatives and select the preferred one. It involves estimating the costs and benefits of each alternative over a specified time horizon and applying a criterion to rank them. Engineering economic analysis can help engineers make rational decisions that maximize the value of their projects. Some of the steps of engineering economic analysis are: Step 1. Problem recognition, definition and evaluation. This step involves identifying the need or opportunity for a project, defining its scope and objectives, and evaluating its feasibility and constraints. Step 2. Development of the feasible alternatives. This step involves generating and screening different design options that can meet the project objectives and satisfy the constraints. Step 3. Development of the outcomes for each alternative. This step involves estimating the cash flows, revenues and expenses associated with each alternative over the project lifecycle, taking into account factors such as inflation, taxes, depreciation, risk and uncertainty. Step 4. Selection of a criterion. This step involves choosing a method to evaluate and compare the alternatives based on their economic performance. Some common methods are payback time, return on investment, net present value, internal rate of return, benefit cost ratio, etc. Step 5. Analysis and comparison of the alternatives. This step involves applying the chosen criterion to each alternative and ranking them according to their economic attractiveness. Step 6. Selection of the preferred alternative. This step involves choosing the best alternative based on the analysis results and other considerations such as technical feasibility, environmental impact, social acceptability, etc. Step 7. Performance monitoring and post-evaluation of results. This step involves tracking the actual performance of the selected alternative against the expected outcomes, identifying any deviations or problems, and taking corrective actions if needed. Engineering economic analysis is a dynamic and iterative process that requires constant updating and revision as new information becomes available or as conditions change. Some examples of real-life case studies and success stories involving engineering economic analysis are: Case 1. Economic analysis of highway projects in Washington State. This case study illustrates how the Washington State Department of Transportation, WSDOT, conducts economic analysis for highway projects using a spreadsheet-based tool called the Highway Construction Program Economic Analysis System, HCPEAS. The tool allows WSDOT to estimate the benefits and costs of different project alternatives and rank them according to various criteria such as benefit cost ratio, net present value, internal rate of return, etc. The case study shows how HCPEAS was applied to a project involving the widening of a section of Interstate 5 in Tacoma and how the results influenced the decision-making process. Case 2. Engineering economy analysis for a new product development. This case study presents a hypothetical scenario of a company that is considering developing a new product called the Smart Pen, which is a pen that can record and store audio notes. The case study requires students to perform an engineering economy analysis for the new product development project, taking into account factors such as market research, product design, manufacturing costs, sales projections, cash flows, taxes, depreciation, etc. The case study also asks students to compare different financing options for the project and evaluate the sensitivity of the results to changes in key parameters. Case 3. Engineering economic analysis for manufacturing competitiveness. This case study demonstrates how engineering economic analysis can be used to improve the competitiveness of a manufacturing company by reducing costs and increasing productivity. The case study involves a company that produces metal parts for various industries using a stamping process. The company faces challenges such as high scrap rates, low quality, long lead times, and high energy consumption. The case study requires students to analyze the current situation and propose solutions using engineering economic principles and tools such as break-even analysis, cost-volume profit analysis, return on investment, etc. Tool: HCPEAS. This is a spreadsheet-based tool developed by the Washington State Department of Transportation, WSDOT, to conduct economic analysis for highway projects. The tool allows WSDOT to estimate the benefits and costs of different project alternatives and rank them according to various criteria such as benefit cost ratio, net present value, internal rate of return, etc. The tool also incorporates factors such as inflation, taxes, depreciation, risk and uncertainty into the analysis. Some of the scientists related to steps of engineering economic analysis are: Zahid A. He is a professor at the Department of Mechanical Engineering, Jamia Millia Islamia, New Delhi. He has published more than 100 articles in national and international journals on engineering economics, optimization, artificial neural networks, fuzzy modeling, etc. He is also the co-author of the book Engineering Economics with Applications. Ted G. Eschenbach. He is a professor emeritus of engineering management at the University of Alaska Anchorage. He has taught and researched engineering economics for over 40 years and has authored or co-authored several textbooks and papers on the subject. He is also the editor of The Engineering Economist, a journal devoted to engineering economic analysis. John A. White. He is a distinguished professor and chancellor emeritus at the University of Arkansas. He has been a leader in engineering education and research for more than 50 years and has written or co-written several books on engineering economic analysis, operations research, industrial engineering, etc. He is also a fellow of the Institute of Industrial Engineers and the American Society for Engineering Education. Osama Muhammad El Mahdi Suleiman Kyle. He is a professor at the Nile Valley University, Sudan. He has published several books and papers on engineering economics, building economics, fire protection economics, etc. He is also the author of the paper Fundamentals of Economics Analysis in Engineering Projects. Bilal M. Ayyub. He is a professor and director of the Center for Technology and Systems Management at the University of Maryland. He has taught and researched engineering economics, risk analysis, decision analysis, systems engineering, etc. He is also the author of the book Risk Analysis in Engineering and Economics. John M. Watts Jr. He is a professor emeritus of industrial engineering at Texas A&M University. He has been involved in engineering education and research for over 40 years and has written or co-written several books and articles on engineering economics, operations research, statistics, etc. He is also the co-author of the book Engineering Economics.